So this problem is from Tropic Sun, which is orange company in Florida. They have 3 groves to produce citrus, 3 locations of farms. And also they need to ship those oranges to 3 different processing plants in Ocala, Orlando, Leesburg. The oranges coming from 3 different towns: Mount Dora, Eustis, Clermont. The farms can produce 275,000 bushels of citrus from Mount Dora, 400,000 citrus from Eustis, 300,000 bushels from Clermont. And they need to ship those citrus to 3 different processing plants because each processing plant has a limited capacity. And even they want to find the nearest processing plant to minimize total transportation cost. And maybe a processing plant cannot handle all the number of bushels. The processing capacity of processing plant in Ocala is 200,000 bushels, and the capacity of Orlando is 600,000 bushels, and the plant in Leesburg has a limited capacity of 225,000 bushels. So the farm needs to decide how many bushels will be shipped from each grove to one of these processing plants. So the farm contract with trucking company. So they need to pay trucking cost, shipping cost based on bushel miles. Bushel miles is how many bushels will go how far in terms of miles. It can be ton kilometers, ton miles, bushel kilometers. So in this example, we use the unit of bushel miles. So like you see from the slide, we have a supply and processing plants. These are the origins. These are the destinations. You can say these are the farms, groves. These destinations are processing plant. You can say this is I, processing plant, a J. So each grove has limited capacity of supply capacity, and each processing plant has processing capacity. So the question is, how many bushels will be shipped from Mount Dora to the first processing plant? Let's say these X bushels from 1 to 1. So how many bushels from grove 1 to processing plant 2, X12? How many bushels from 1 to 3? That means our decision variables is number of bushels from grove I to processing plant J. You see this? So from grove 2 to processing plant 1, that's going to be x21, x22, x23 from grove 2 to processing plant 3. So that's our decision variables. So decision variables xij or x11, x12, x13, x21, x22, x23, x31, x32, x33. So we have 3 times 3, 9 decision variables. Like this. So next step is formulate objective function. From this example, so minimize total bushel mass and bushel mass. So from Mountain Dora to Ocala is 21 miles. Right? So if we have number of bushels from Mountain Dora to this is 4. Sorry. 4, 5, 6, 4, 5, 6, 4, 5, 6, 2, 4, 5, 6. So 1, 4, and your distance is 21. If we decide to have an X number of bushels from Mountain Dora to process plant at 5, so your distance is 650. Right? So now you see the pattern. So X 2, 4, where the 35 miles plus X 3, 2, 5, 30 miles plus X 2, 6, 22 miles, and plus X 3, 4 times 55 miles plus X 3, 5, 20 miles plus X 3, 6, 25 miles. So this is your objective function. Do you have any questions? Okay, let's take a look at constraints. So what kind of constraint do you see? So I see two groups of constraints: supply constraint and processing capacity constraint. I would say from 1, 4, the supply from group 1, x14 plus x15 plus x16 should be equal to 275,000 bushels. Is that correct?
Yes.
Then from group 2, x24 plus x25 plus x26 should be equal to 400,000 bushels. And from group 3, x34 plus x35 plus x36 should be equal to 300,000 bushels. Now let's take a look at the processing plant capacity constraint. The amount of bushels shipping into the processing plant or SEA, Ocala, will be x14 plus x24 plus x34. Do you understand?
Yes.
Okay, that should be less than or equal to 200,000 bushels. Because the processing plant may not have 100% utilization. So we can say that less than or equal to. Now the second processing plant in Orlando would be x15 plus x25 plus x35 should be less than or equal to 600,000 bushels. We do the same way for processing plant 6, x16 plus x26 plus x36 should be less than or equal to 225,000 bushels. And non-negativity constraint. These decision variables should be greater than or equal to 0.